Good afternoon, everyone. I would like to thank the Green Building Council to invite me over here. This is my second private visit. This year, I was here in last February 13 to speak on the Metropolis LOCD's concept on the facade. So here, I would like to talk about the facade design, which can help onto the sustainable facade, can bring the energy efficiencies on the building. So as we all aware of the facade, which is the envelope of the building, contribute a major role in terms of the energy efficiency, giving the end user a comfort level as well as also the cost-effective solutions in terms of the operational cost and the maintenance. So I would like to run through some case studies on the facade, which is sustainable in few of the projects where we have So some of the facade design which contribute the sustainable, cost-effective solutions. So the facade design into the building, which is a very, very important role in terms of the giving the end comfort to the buildings. So there are few criteria which are very important, few factors are important, few studies need to be carried out before designing a facade, which we call it a sustainable, energy efficient facade. So those are like certain studies, the daylight analysis of the buildings, the sun path analysis, the shadows, the material selections, and so here we go with the facade design, which cater to the concept and typologies. So concept plays a very, very important role at the initial stages with the architectural team to understand the geometry of the buildings and how can the facade can be designed with the energy efficiency. Not only cater to the material selections, but also the architectural intent equally important. In terms of getting more visions where you have the daylight to come into the buildings, less using of aluminum or the metals into the buildings. So, first of all, the facade engineer or the facade consultant is very, very important at the initial stages to derive the energy efficient building. So here we go with the concept and typologies, the facade lighting, building maintenance systems also, because using a building maintenance BMU systems over the building which have more electricity consumptions, so we can have a different options in terms of getting placed of the building maintenance systems. The material studies plays a very important role over here, and the value engineering is not only the cost effective, but also how do we select a better equivalent product which give a thermal insulations to the buildings. So the concept and typologies, the building maintenance system, the mental stages, these are the important and the initial stages before we're getting into the facade design. So what is sustainable design? So sustainable is the triple bottom line, is the social, environmental, and the economics. So economics reduces the energy cost, the protecting the bottom line. That's how the sustainable design is meant for. The facade controls parameters. These facade control parameters, like when you design a facade of a buildings, there are certain parameters which control the surroundings, the wind, the solar energy, the rainwater, carbon dioxide, transpirations, noise, and dark. So all these factors has to individually attend before we getting into the energy efficient or maybe a good facade design which bring the end user more comfortable as well as the reducing the operational cost or air conditioning cost, whatever you say. So here some slides like with the commercial facade designs, what are the factors like where the air conditioning and the heating consuming. So let's take an example of the commercial buildings. 48% of air conditioning and heating on the commercial buildings, 11% on the lift and escalators, 19% on the lighting, the facade lighting, and 22% of the office equipment. So while we design the facade on a commercial building, these are the criteria we need to take it into the considerations. How do, for example, office equipments. So inside the office equipments, mostly the artificial lights, the air conditionings, and the internal arrangements. But mostly, how do we control the artificial lights for the facade design? So we should have a glass which allow the daylight to come in, but it should cut the heat or solar glare through the glass. So selecting of the glass in a commercial building, it is very, very important. So where we can reduce the artificial light and allow the more daylight in the office premises as a natural light for the end users. So air conditioning and heating, yes, the same thing like we should go with a combined analysis, not only the glass, but it should have a framing and the glass composite combined analysis, which we call a UCW value, which is very, very important to reduce, to get the energy efficiency or to cut the solar glare and allow heat inside through the system from outside to inside. So this helps the facade design parameters in the right selection, help the mechanical or MEP guys to work out equally to control their air conditioning or inside areas. Facade lighting, yes, exterior facade lighting, which also created heat. So this facade lighting can be selected with there are different materials are available now for the facade lighting, which give you a better aesthetical the lightings, but it can also control the heat zone. Equally, the residential buildings also, the 10% of the score, the conditioning, 18%, the 22% of the lighting, and 50% to the lift escalators. The facade, right facade design on a residential and condominiums are equally important. Yes, we do understand like the residential, the 66% of the global, the residential, the areas are opening because it have a lot of windows, but using a thermal control or maybe insulated product on the surfaces if the building more cooling. Mostly these residentials, the performance are more are used in applicable in the Middle East, probably in Dubai or maybe the UAE regions where the facade plays an important role on the residential complex. So the global energy efficiency, what we call as, is saving, contribute to the 12% to 15% saving over the base case. So the global scope of a facade design start with the architectural concept. So as I have mentioned before, that architectural intent is very, very important because this is the the aesthetic requirement for the architects and the owners for their own projects. So study of architectural concept, the aesthetic feasibility, the performance criteria, safety, security, and easy maintenance. So these are the global scope of the facade designs where if we talk about the energy efficiency, so energy efficient design can be done in any kind of building. It did not have to get a points for getting a LEED certified like a gold or platinum. but this energy efficient design help on day-to-day basis on on saving or giving a cost effective. So the performance criteria here is like either to the daylight. Daylight studies are important for the comfort as well as selecting of the facade. The thermal analysis, which I mentioned about the U value, UCW value is combined for the glass and the aluminum. With simulation, there's the structural points of acoustic, energy, and the facade lighting. So I'm just going to run through a few slides about the green building certifications, like starting with the Platinum Plus, Gold rated buildings which have been designed globally. So here the first case, we turn commercial buildings which have a double screen facade. The intent of the architectural concept to block the inner facade with the outer facade, which is a screen or maybe a different materials, where you have the visibility blocked from outside to inside, but it should have an inside to outside visibility. So these are more or less into the parametric studies, but also it cuts the solar heat which is coming to the glass, through the glass. And in this case, on the double screen, if you have the first screen to be designed as per the solar sunpath analysis requirement, then you do not have to go with a very high performance glass inside. So these are certain parametric studies, like where the visibility factors have been run through the different placing of the pipes. They're the first options, and you can see through from inside to outside the visibility. 74% we can receive, we can get maximum. Certain daylight studies been done through for the comfort of the second screen here. The second options, not to go with the verticals, but also bit on the aesthetical more improvements, going with the perforated screen over and the first and second screen remain as a glass screen. The option trays with some corrugated with a different pattern. So there are different options can work out during the concept and schematic design stages, and where the final solutions of the architect requirement and the owners let's go with the perforated screen, which is 58% perforations. You have the daylight studies through it, and the inner facade and outer facade getting an aesthetical as well as performance as per the requirement. Then after the parametric studies go with the setting analysis. These are all process of the energy studies, because the geometry of the project is somewhere like in the block over a block. So certain areas where may not need to go with a high performance glass because of the shading. So all the analysis required to be done before we come into the facade system solutions. Some of the maintenance systems, like going with the building maintenance system, which is very heavy and it consumes a lot of electricity, or maybe the motorized, it needs the fuel. So instead of going with a regular cost, some mechanical, which does not require any power or more power to run the operational systems. This is the power grid headquarters, which is the LEED Platinum Plus buildings, which got all the facade elements starting from the solar, photovoltaic, the green planters, the water harvesting, electrochrome glass, the thermal brake system been used because it's a Platinum Plus rated buildings. So I'll just quickly run through the sides. So here the facade, you can see the facade over you got the combinations of the vision panels, the spandrel panels, and some of the planters and the glass fields. So these combinations where we run through the daylight studies, or the thermal and the sun path analysis, and where if you refer to these sections, you can see that there's the false wall behind it, which is a self-ventilated, So when the heat falls on the sun rays over here on the glass facade, it allows the more light to come in, but it cuts the glare and the heat through the selections of the glass. And whatever the heat which is passing by through it is again circulate from the. So these are all different types of the facade concept or the design can be worked it out together, and with the mechanical guys and also with the architectural team to achieve the required details. Finally, the U value over here we got is a 1.3 and combined U value for the framing and the glass. This is the thermal break barrier systems where we got we call it's a coconut planters which is connecting through the facade. And you can see none of the aluminums are exposed. So those are all the isolator or EPDM rubber which is connecting each other and where the heat cannot be transferred inside. So there are various systems where the facade design can be done. It's not that the facade designs and the cost-effective design is not required to be going with expensive facade design, which is not be required sometimes, and value engineering or maybe the tweaking on the systems can bring us or get us the required parameters. The solar panels, photovoltaic panels, and the roof panel switches, or maybe on the facade, where the glass solar panels, you get the less power generation capacity, more aesthetic. In this project, the thin film solar, there's some solar facade being installed in this project for the monocycline, the solar panels, and polycrystalline solar panels. These are different. There are different types of solar panels which are now integrated in the facade, maybe on a vertical facade or maybe a roof facade. So the photovoltaic panels design here, yes, the facade plays an important role. Like there are two aspects over. One is the placing of the solar panels, the angle of inclinations, which is important because it's directly related to your energy generation, the consumptions. And the second aspect is how do we get the proper drainage of the solar systems, from the solar system, so that it keeps dry. So the facade design lies with the placing on the angle of inclination and we call it the gutter systems where it should be the water should drain properly. So water harvestment scheme or the cleaning systems of the solar roof that we've been designed just now at this conference. There are some new innovative materials or the products are available which are electro-chrome glass. Now I think probably many the new facade will have electro-chrome glass where you got automatic changing of the color of the glass based on the sun falling onto the surface. You can see the color changing slowly. It depends on the angle of inclinations. So if we use this kind of glasses, then we need not have to have a venetians blinds on the glass to put over. And this is an automatic process where based onto the sun hitting onto the glass, you get changing the colors. So these are some innovative materials which are using, which are nowadays it is coming up into the facade. The second, the projects over here in Jakarta, the Mineral Palma, which is a facade, the design concept from the article architect from US. So here the main concept is to divide the facade with a shading device. Over here, this is somewhere around 600 millimeter, the shading corrections. So this shading plays a major role on cutting the glare, and where we need not have to have a very high performance or costly glass to be used over. So the analysis through on this facade runs through the angle of inclination where the certain part of the glare can be cut for the sun through this the setting devices, and using an insulated IGU glass is very important for any kind of projects, which is maybe a commercial or maybe hotel or residential condominiums. It doesn't cost much if you rightly select the glass and the thickness of the glass as isolated glass, which give you a lot of saving for the long run in terms of the performance and also in terms of your acoustic control. There are some systems where quickly run through it. There are systems where the thermal brake systems have been used over here. That's how the facade is. So you have the setting, which is also help out to determine the glass, maybe the cost-effective design, as well as the energy efficiency. The facade lighting, the facade placing of the facade lighting, it should not have more the diffuse light to be falls onto the glass, as well as the aesthetic and the performance. It's affected that. And mostly for the sustainable or maybe the energy efficient building, which there are many different products that are available, not only used to go in the metal cladding on the surface. There are many other materials which are the insulated product or the natural product, like the glass reinforced concrete or maybe the precast panels or high pressure laminated. These are all natural products, can be used instead of the metal cladding, which can give the building more cooling. Some green walling concept, also this comes out, the green walling, the precast, the precast panel. These are different product, can be used on the building to the building more cool as insulated for the thermal barrier as well as the acoustic control too. Some of the green options here, like the green, we call it the green walling system. So it is very important to select the right concept of the green walling because of the maintenance, the irrigations onto on the planters. So few precast panels nowadays, mostly they use in India. It's quite famous, familiar with the precast, and the Middle East projects, Middle East areas, they use most of the precast because of the heat over there. So some of the glass details, like insulated details, yes, insulated glass is important. We should always prefer to go with the insulated glass on the facade. So these are this is a hotel project. So here you got the hotel room studied with the daylight analysis, and then your glass divisions depends on to that the selection of the glass for the hotel building, especially most of the thermal as well as the acoustic is very important there for a hotel. Certain analysis on the window side where your DLF, daylight factors has been determined into that. Coming back to the thermal analysis, why it is important? Because thermal analysis is a study which gathers between the glass and the aluminum. So when we're talking about the facade, so facade contain majorly nowadays the modern buildings are combination of the glass and aluminum systems. So aluminum is a good conductor of heat, so we should have a system which is thermally broken. So we should break the heat from outside to inside. There should not be any heat or maybe a less heat with transport for the metals. So how can we do that? We can design the systems with not exposing the aluminum on exposed to the sunlight. So we can have different various systems can be introduced there, which can have less heat to be transferred to control the heat. And the second important is you have also a better acoustic control. So thermal and acoustic, these are the very important two factors for any building, especially the hotel or maybe a commercial which is closer to the traffic roads. These are the certain studies, case studies of the thermal analysis where the framing and the glass equally been studied with the thermal. These are the different colors where you can see the thermal graph of the heat. And the conditions like this is a window walling framing on the glass is 24 millimeter DG clear glass because the hotel, the solar factors, the internal reflection, external reflections and the UV. The internal reflection is also important because you have to see yourself mirror at night. And that's how this analysis combined get into the UCD value combined global thermal analysis. So as a facade engineer, we do study with this combined analysis of the thermal value, which give it to the mechanical MEP guys or air conditioning HVAC guys to work out their internal arrangement on the chiller, determining the chiller or maybe the loading consumption. This is another hotel JW Marriott, which is just near to the landing runways. Is more highly acoustic, thermal, as well as is an anti-blast proof facade. So the sizing, the window sizing structure, large vision areas, ample of daylight, window setting, design sunshade device, the ceramic fittings, glass selections, performance of the glass, clear, heat, thermal control, safety and security. These are the certain types of the well-treated glass selections. The color of the glass also plays a major role in defining the energy efficient building. Yes, mostly the clear glass having more visual light transmission where you have a more heat to come in, but there are some specialist clear glass which can be used, which we call as a low density, low E glass with the different levels and having insulated can also go with the clear. Insulated glass, you have a first layer and a second layer of the glass with a spacer, you have a cavity, which is normally more in the Southeast Asia, probably they're using of 12 millimeter air gap. So as a facade engineer, we do have a lot of experience in on the glass placement of the air gap over. So if, for example, if you use a 16 millimeter air gap instead of 12 millimeter air gap, what will happen? When you use a 16 millimeter air gap, then you get better U value. So the ratio of 12 millimeter to 16 millimeter air gap, we get 0.2 better U value in 16 millimeter air gap. And if it relate to the cost of the differential cost between the 4 millimeter air gap between the two glass is just negligible in terms of the volume of the projects. But you get a better U value for the glass. So these are the spacers can be used based on the requirement of the project. If it is more concerned on the acoustic, more concerned on the thermal, then we can place with the different. Maybe we go with the air or maybe argon or krypton gas filling inside the spacer of the glass. So this glass is a major part of the facade, which this should be designed correctly to have a proper energy efficient facade along with the systems. Some acoustic glass, just like the present for acoustic glass, like there are different layer of the glass laminations, what they call as PVV laminations or central laminations. Different type of laminations are available over. So there's a difference between the lamination glass, PVV laminations and the central laminate glass. So like the clarity for the PVV is like dualistic, central is ultra clear. So normally the central glass, laminated glass are using mostly on the railing
the residential blocks or maybe any projects with the railing or the soft front where you need to have a more visibility and the safety. Safety is important. So Sentry give a better safety because it has more elasticity into with their properties. So the color options, age performance, the impact, post glass breakage, the acoustic, the sealant compatibility, security, sizing. So these are the different differences between the PVV and the Sentry. Both are laminated, but the different composition of the metals which can be selected with the facade. Few of the projects, for home projects, this is a Michael Shoemaker Tower in India, which is now building up. A few residential and condominium projects with a different height. This is 98-story, 310-meter double-screen facade with the mixed-use developments, again residential and a hotel. The Maria Sorpa, she is the owner for this building. It's a very complex building in terms of the facade. Few commercial, these are again a green. This is educational park, purely a green buildings, green certified buildings. The laboratory, platinum green certified buildings again. Islamic Bank at Doha, Qatar, which is one of the very complex and energy efficient design has been done over. So most of the project it seems nowadays are the energy efficiency, what you call as energy efficient sort of facade design. Few hotel projects like the Hilton or maybe Western Hotel or JW Marriott, these are all LEED certified projects. Some institutional projects, platinum, again the platinum under the Griha, platinum rated university, National Institute of Security Management in Mumbai. This is a powerhouse headquarters, the government projects, the Grand Red Line stations in Bangkok. This is where we contributed our design in the facade design in this project. Again, the MMRD headquarters in Mumbai, which is a LEED gold-rated platinum. So if you see, like most of the projects are nowadays coming up with the LEED certified buildings because the energy efficiency, the definitions, the caters to a design which can give a comfort to the end user as well as also can have a cost-effective the solution in terms of the overall the building performance. Some thermal analysis report I'd like to quickly go through why it is important required for thermal analysis on the spandrel part, which is coming in front of the slab, and this is at the bottom where you got maximum heat can transfer, flow in and out. So here it is very important to study to know the heat transmissions through or flow through this part. So there are different components we need to study before getting into the facade design. So this is again the systems. This is the main system. You see the glass buildings. You have a vertical aluminum members, which you call as a split mullion for unitized, and then you get the glass. So the heat path through this and certain studies, again the same thing, the daylight thermal, the climatic conditions is important also to understand because of the aluminum coating surfaces. So some of the slides with your daylight studies, the options with the different glass with the daylight to study on the daylight for a clear and color glass. So these are various processes where the facade design can be done with an energy efficiency. Thank you.